All right, let's go ahead and talk about Lewis valence electron dot structures, which are very, very easy. So, Lewis valence electron dot structures show the symbol of an element with its valence electrons around that element. And so, valence electrons are the electrons that are on the outermost energy level, and the valence electrons are also very important in understanding how elements chemically react. And so things that have one valence electron tend to all react the same. Elements that have 7 valence electrons tend to all act the same. And elements that have 8 valence electrons, again, tend to act the same. They tend to behave the same. And so what we're going to do is use these following steps to write valence electron structures, so Lewis valence electron structures. And so the first thing we want to do when writing a Lewis valence electron dot structure is to write the element's symbol. And the next step is to determine the number of valence electrons, and so you want to determine that by looking at the group number. For example, if something is in the first column, that's going to mean that it has 1 valence electron. And so group number refers to the column. Now when you look at your periodic table, what you specifically want to look at is the number that has an A with it. So you want to look at 1A, 2A, 3A, 4A, 5A, and so on, because it's those columns that tell you the number of valence electrons. Now what I'll say is the transition elements that are in the middle, the D block and the F block, we're going to talk about how many valence electrons those have later on. But when we add electrons to those particular elements, what will end up happening is, for example, the D block, as the electrons get filled, they don't go in the outermost energy level, but they go down a level. And so, for example, the 3Ds are in the 4th energy level, or I'm not in the fourth row, and even though they're in the 4th row, they get put in the 3D, so they don't contribute electrons to the valence electrons. So, the next thing you want to do is, once you determine the group number, that happens to be the number of valence electrons. And so if you look at fluorine, that's in 7A, and so that means it has 7 valence electrons. Then what you want to do is you want to start on the right of your element and move counterclockwise, putting a dot every 90 degrees. After you've put 4 dots, what you will then do is you'll start to pair up those dots. So for example, if we were to put 5, if we had 5 valence electrons, we're going to go 1, 2, 3, 4, and then we pair them up. And so we're going to look at an example here in a moment. And so again, here are the different groups. Notice how the transition metals get skipped because the transition metals don't contribute electrons to the valence level. And so let's go ahead and again, each column is called a group, and each element in the group will have the same number of electrons in their outermost energy level. And so you'll see that the first column is group 1, then group 2, and then we skip over to the column that has boron in it, and that's going to be 3, and then 4, 5, 6, 7, and 8. Helium is an exception though. Even though helium is in the last column there, it's only going to have 2 valence electrons because helium only has 2 electrons. So let's go ahead and take a look here. So let's take a look at carbon. Carbon is in the 4th group, so that means it has 4 valence electrons. And so when you add the valence electrons there, you're going to go 1, 2, 3, 4, and that is the Lewis dot structure for carbon. Let's go ahead, and what I want you to do is just pause the video, and I want you to write these elements down, and I want you to figure out the Lewis dot structure for them, and then I'm going to go ahead and go through all of those elements there. Alright, so hydrogen's in the first column, so it has 1 valence electron. Phosphorus is in the 5th column, so it's in group 5A, so it's going to have 5 valence electrons. So we go 1, 2, 3, 4, and 5, and notice how the 5th one pairs up with that first one there. So again, we go 1, 2, 3, 4, and then they pair up. Calcium has 2 valence electrons, so there we go. Argon has 8 valence electrons, so 1, 2, 3, 4, and then they pair up. So again, you go 1, 2, 3, 4, and then they pair up. And notice how we have 4 pairs of electrons. Chlorine has 7 valence electrons, so we go 1, 2, 3, 4, and then it pairs up. And notice how it's going to have 3 pairs of electrons with 1 single electron, and that will be important later on. And then aluminum has 3 valence electrons, so 1, 2, and 3. And that's it. So Lewis dot structure should be very easy because you just look at the group and then you write the dots around there, and that's it. Now, what I want you to do is go ahead and write the Lewis dot structures for all of these elements. Look at the answer key on my website to make sure that you got it down. And what you will see is that each column should look the same in terms of the orientation of the dots. And that's it. You guys have a great day.